You guys want to be the zoom in, the zoom inner over here?
Be the zoomer.
The zoomer. I lost my hat there. Can I take it up there?
I don't know, sorry, set it here.
What?
So did you set it here?
Well, I guess we'll start. But thank you guys for coming. For those of you who I don't know, hey, come on in, grab a packet. I'm Sarah. You know, this is my classroom. I am one of our second grade teachers, so thank you guys for coming to do this. Basically, the reason behind doing this is that we wanted to make sure that if you felt stressed about math, that you could come and understand what this next chapter is, because this is by far the most complicated one of second grade, and then you could feel comfortable with it, but also kind of have a little bit of an understanding of why this is important for not only our math series, but in general for math. And this first page does talk about it a little bit, and the paragraph at the bottom, I think, kind of exemplifies why this is a good idea for us to learn this. It talks about how in the U.S. students are typically taught a variety of strategies for solving problems, and one of them is drawing a picture. Come on in. You can sit wherever, there's a packet right there for you. But in general, we were taught more about keywords and not necessarily to be able to use that picture to actually understand the math, at least not as problems become more difficult. Pictures and numbers and representations that we probably were taught were like, there were 12 chickens and you drew 12 circles. And then they each had a piece of corn and you drew 12 pieces of corn. And then you were able to figure out how many chickens and corn there were. And that's fine when there's small numbers like that, but as soon as the numbers start to become larger, you can see those kids drawing 300 circles on their paper, and then they miscount, and then they got 299, and they spent 3 hours drawing circles, and it's not really effective. So the idea of the bar model is a way to visually represent data and information in a simple, easy to draw, easy to manipulate, easy to organize method that will translate not only to these somewhat simple problems that we're doing here in second grade, but as you continue on throughout the upper grades, up until even into high school area and so on and so forth. So there's two examples of we'll go through a variety of examples of problems. But the first one on there, is not a second grade problem. And I'm going to let you guys try and solve it in any way that you want. I'm going to read it to you, and then you can try and solve it how you want to solve it. And I want to see if anyone's able to solve it easily, if it's difficult for them, and how you guys kind of felt about it and your ways of solving it. So it says Jessica and Lillian had the same amount of money. Jessica gave $1,140 to a charity, and Lillian gave $580 to a different charity. In the end, Lillian had 9 times as much money as Jessica. How much money did each girl have at first? How much money did they have in the end? You get 5 minutes, go.
Yeah, okay, we're timing you.
Yeah, there are some pencils
Oh,
here.
in their desk, they probably can just open it.
You better pay.
You can come sit at an actual desk if you want, as opposed to over there.
No cheating.
I don't want to spoil it. I'm giving the answer. I would do it, but.
You're fine. You don't have to move or anything. Dr. Ann, do you want to solve our challenge problem too?
Oh, did the gals tell you I was looking for you today? Because I was wanting to check my answer. Because I already did it this morning.
Did you?
And I was like, Becky, do you have an answer? She's,
My answer's still 0.
I don't think she's even ready.
so,
I donated all my money.
This is right.
and then,
Yes.
okay.
Thank you.
So then back
Are
here,
you
right?
proud of me or what?
I am.
I was like, how did you determine to figure that out?
Hey, come on in.
It's been too long since I.
Or you can come sit at a desk. You can sit in a little chair here.
Does
this bring back terrible high school
Everybody's starting to sweat.
Yeah.
This time, we're solving the first problem in here, any way that you want,
Right.
or at least trying to.
You need to specify.
And it's not fair.
I want to see him explain it. But you can do it. Does it take you a while?
You know, I knew I needed to solve for X. And,
Yeah.
yeah, the first portion of it. And then I was like, okay, yeah, then I gotta go on something.
Yeah.
So then I assigned you. Don't ask me, honest. So then, so she said, go ask Alicia.
Oh, yeah,
I ran her.
yeah.
She goes, you got it, you got it.
Yeah, she and I did it hard.
Don't worry, it won't be blank for long. It'll make more sense.
So I see, and I was not. Really more geometry.
Oh, so you're
And that's geometry.
yeah.
That's true. Yeah, beautiful, yeah. Yeah.
Not at all.
Yeah.
But I did take an extra copy from you.
Anyone think they got it? You do?
I think so.
Do you want to show your work on the Elmo?
Well, you can come back here and share.
This is what we do in class.
This is what we do in class.
You can hand it to Mrs. Newman, she can put it back there, and you
Put
can.
it back there, unless you want to explain it, or do you want to do it?
I'm sorry, I don't mean to put you on the spot.
Yeah.
High stress situation here in second
Oh,
grade.
actually, he doesn't,
They're usually like,
you didn't write it on here, you just have it.
It's right here. It's on the front page. I didn't see that it was on the
Oh, wow, okay, all right.
Man, he doesn't even need the whole page like I did.
That's what it say.
Can I turn the light out or?
no,
Oh, yeah, we got it.
the one, you can do the one if you want. Will you push the button on the end?
Yeah.
If I'd known this one up there, I would have been neater.
You got it. That's fine.
All right, well, this is the way that I solved it initially too, but do you want to tell us what you did?
All right, yeah, you're trying to find the same amount for each person, so I did that with X. And then X minus 580 was for Lillian. And then you're looking for 9 times what the difference is between X minus 1,140. And then take the 9 times, subtract. I had to do it a little bit different, but add back the 10,260 to the 580.
That went there and that went there.
Yep, minus the X, you have 8X equals 9,680. Divide by 8 equals 1,210 each. Minus the 580 is Lillian has 630, and then 1210 minus the 1140 is 70 for Jessica.
Exactly. So right here, fabulous job.
Nice job.
And thank you for sharing. Impressive, impressive.
Yes.
Flip it back to the other. You can turn the light back on. So clearly it's complicated. Clearly if you don't have a pretty good understanding of how algebra works and how to build equations, this problem is something that is kind of unreachable for a lot of us on a general day-to-day thing. If you were in this math class, it might not be that. If that was what you were studying right then in math, like I remember doing that back in whatever math class. But the idea of bar modeling creates a way for us to solve this problem without it being so abstract. And so this drawing is probably going to be terribly not to scale. So just give me a bar modeling starts with a rectangle. So we're going to start and we're going to draw a rectangle here. And that rectangle can be for Jessica. And then we're going to draw another rectangle, same size, and that's one's for Lillian. And the reason they're the same size is because they started with the same amount of money. So then it says Jessica and Lillian, they're both going to give away some money. So Jessica's going to give away $1,140. So what we're going to do is we're going to divide her bar into 2 chunks, and part of it is going to be the $1,140 that we're going to be giving away. So I'm going to divide it here, because I feel like $1,140 is a lot of money to give away, and I draw my terrible swoop there, which we usually call a bracket or a brace, and that's my 1140 that she's going to give away. This is how much she's going to have left. Then it says that Lillian,
Do you need it?
well, will you leave the number and the
Oh,
numbers
sure,
up there
okay,
so I
sure.
can see
I
them?
didn't know if you needed that, sorry.
I-
I just thought it was a bit more of a glare than
Oh,
it needed to be,
well, I guess
sorry.
it doesn't need to be up there then. I can
Okay,
remember
it's
the
fine,
numbers.
it's fine, I can put it back, I apologize.
No, it's okay. I just thought maybe I stepped on a wire earlier and things went off.
No, I
So
didn't.
then Lillian's gonna give away 580. So obviously her amount that she's giving away is less than the amount that Jessica's giving away. And so I'm gonna divide her bar differently. I'm gonna make her amount be less because she's only giving away 580. So I'm gonna make my line there, and this part down here is the 580 that she's giving away. They've both given away some amounts of money. When they are done, Lillian's gonna have 9 times as much money as Jessica. It looks like she's got more money, so we know it's supposed to be 9 times, so we're gonna actually divide this bar into 9 equal parts. They should, if it's to scale, be the same size as this piece. So we can have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. That's our 9 parts that she has, greater than this one part, 9 times. So here we've got a picture of exactly what's happening in this problem. And from this we can make a very simple equation. We can decide to give this one box a variable, and I'm going to call it x. So this is x, and all of these then also are x. I don't have to label them as x, I'm just putting that there so you guys know. And so I can make, since I know these 2 bars are equal, an equation where they're equal. And I can have x plus 1140, that's Jessica, is equal to 9x plus 580. So directly from this picture, I have created a simple equation here, which then is one that we can solve relatively easily. We can subtract the x, so we have 8x over here. We can subtract the 580, which does that give us, what, 6, no, what does that give us left over here, 630? No, 56. 560 over here. And then we solve for x. X equals 70. So this one x is going to be 70 right here. That tells us that when Jessica's done, she's got 70 left over. And for Lillian, we know she has 9 times that. So she's got 9 times 70, so she's got 630 left over. So we figured how much they had left over. We can plug that same number back in to figure out where they started. X plus 1140 is going to give us where they started because they're the same amount that they started with. So you really only have to figure that out the one time. So 70 plus 1140, that gives us the 1230 that they started. Was it 1230? 1210, excuse me, that they started with. Does that make sense? How we went through this process and where we got the equation from the bar model? Does that make that problem easier for you guys to see it represented that way? I thought it made a whole lot more sense, and I solved it the other way because that's how my brain worked and that's how I was taught to do math. But the idea of representing the numbers in these simple rectangles allows someone who maybe doesn't have that great understanding of math to be able to decipher it and make an equation here. So when we're adding 2-digit numbers and they're saying, we don't need to draw a bar, I know I'm just supposed to add, it's because this is ultimately where they're headed. They're headed toward these more complex problems as they continue in the upper grades. And what this does is when they get to those algebra classes and they have to think through these, they immediately will be drawn to, let's draw a bar. Let's start here. Let's label what we know. Let's divide these bars easily because it's just straight lines. It's easy to do. Questions on that part? Okay, so if you flip to your next page, now we go to 2nd grade. And guess what? You'll feel like a genius now.
Even the teachers can do these.
Yay! I am accelerated. Will you go to the top one? Is it? Oh, this is
That's
what
it.
Helen. All right. We talk about food a lot in my class. Today we did a whole problem about donuts, and yesterday we did about breadsticks. I think we're hungry all the time when we do math because it's like leading up to lunch, so many of these have food in them. Okay, so this is a very simple example of part-whole, which is something they talked about a ton in 1st grade with number bonds, where they have the whole and they have the 2 parts, and you add the parts and you can get the whole. So the first kind we'll do, you're going to start with a bar. a basic rectangle. And Helen has 14 breadsticks, her friend has 17. How many do they have all together? Most of you would say, well, you just add them. This is easy. Well, Helen has 14. That's slightly less than what her friend has. So Helen's part of the bar is going to be slightly shorter than her friend. So when I divide it, I'm not going to divide it directly in half. I'll divide it a little bit before that so I can represent that one number is smaller than the other. Then, again, I'm going to draw my crazy brackets, which, by the way, if you ever children draw these brackets, we've had to practice quite a few times. They look absolutely hilarious. They're all just like weird ziggy-zaggy things all over their paper. It's great. So this is 14 that she has, and then her friend we're going to represent in the second half of the bar, and that's 17. How much they have all together, we represent on the bottom of the bar with a question mark. This allows them to see the whole and the two parts, how those two parts are related, and that when you put those two parts together, it should equal the whole amount. Then they can do a simple addition problem, 14 plus 17, most of them did that in their head, and this gives us that answer, and all they have to do is write it down there and circle it. Question, does this make sense how we did this kind of problem? Okay, so this one we would call part, whole. Along with the part, whole, there are subtraction ones. And these are going to be very, very similar, but instead of being given the two parts, they're being given the whole and one of the parts, but the way you design the problem will be exactly the same. So once again, you start with your rectangle, you draw that bar. It says there are 21 fish in a bowl, 15 are from the students, the rest are from the school. How many are from the school? So right away we know, okay, we were given the whole, because they told us how many we had. We know there are 21 from the, or 15 are from the students, and we don't know how many are from the school. So when we divide it, we're going to divide and we draw our thing there, and 15 are from our students. We don't know how many are from the school, but we know in all there are 21. There's a little asterisk there. It says, knowing the part, whole thing allows us to decide whether or not we want to solve with addition or whether or not we want to solve with subtraction. Because from this, many of the students at this level are going to say, I know it's going to be 15 plus some number equals 21. Because I can see a 15 and I know another number's there, and when I put them together, I'm going to get 21. And they can solve this equation this way. That's fine. But it also allows them to see that relationship with subtraction, where if they start with the whole, and they do 21, and they subtract the 15, and they get rid of that part, the amount they have left over in the bar is going to be what they're looking for. So they can do 21 minus 15 to get their answer there. It allows them to do it either way and understand how they're connected. So these are the two part, whole types of problems that they will be solving. For them, it's less about actually physically drawing the bar and more about being able to interpret where and how the numbers go, but they still are learning to draw it. So a lot of times on assessments or on pages that we do, they will give the bar representation already drawn for them, and they'll have to fill in numbers or they'll have to understand the relationship there. But having them practice drawing it is a really good way for them to then, when they look at one that's already drawn, think it's super easy because they didn't have to do that part of it, and they have a better understanding of it. Does this one make sense? Questions here? Okay, next page. This is the one with sets. Mrs. Newman, is that next?
Yes.
Okay, so these are very similar in the type of problems that they are, but instead of being given all the information from the beginning, you're adding a set or taking away a set. Sometimes they say joining sets together. So this one is about Jenny, and she has some marbles, and her friend gives her some more marbles, and then they want to know how many they have. So again, you're going to start with your bar for Jenny, and we know Jenny has 87 marbles, and her friend is going to give her more. So when you do that, you're joining a bar to it. So you're adding that bar on. A lot of times it will look like this. They'll have an arrow drawn in the pictures. You see it like floating in. So we add that bar on, and we know that that one was 78, that joined them. And then from that, we're able to determine we want to look for the whole of the two sets being joined together. So again, once we have it written out like this, they can see I had 87, 78 joined. How many are there all together? And they can do a simple addition problem in order to solve their answer here. This one I think is a little bit harder for them to understand, that you need to join the group on, and sometimes they will draw the whole thing first, and if they do draw the whole thing first, that's okay, because again, they can divide it there and they can see that as long as they understand that something is coming that wasn't there before. Good? This one makes sense? Alright. The next one is, again, the same idea, but this is thus taking away a set. And again, that arrow is something that we will use there. So a florist has 98 flowers. She sells some of them. She has 28 flowers left. How many flowers did she sell? So with this one, you're going to draw your whole bar there. And she has 98 flowers. So we know that's her total of them because she's going to sell some of them and have some left over. So what we would do here is we're going to divide it. We know she's going to have 28 left. We know she started with the whole of 98, and we're looking for how many she got rid of. So this is our question mark, and those are the ones that she sold. One of the things you'll notice is that we always try to put the whole at the bottom and the parts on the top. It just is, if we continue to do that, it's easier for them to recognize where those things are in their bar. So this would then, it would allow them to solve this again 2 different ways. They can solve it with an addition problem, where 28 plus some number is going to give them 98, and some of them will look at that and that's easier for them. They're going to know I have to add 70 to it, right? Because 2 plus 7 is going to give you 9. Or they can do it with subtraction. They can do the 98 minus the 28, and that's going to give them the amount that we're giving away. Not terribly complicated, that one. The last kind of problems here are comparison problems. And until now, all of the problems that we have done only require 1 bar. And in a comparison problem is when you need to make sure that you have 2 bars, because you're actually comparing 2 different things there. So this is the first time that the bar models will have 2 rectangles drawn. And so this is about Grant and Ken. So we're going to do Grant first, and Grant gets his own bar. A lot of times for these you can put like an initial or a letter over on the side so they can remember what is what. So Grant has 345 fruit bars, and Ken buys 230 more fruit bars than Grant. How many fruit bars does Ken buy? So we know that his bar is going to be bigger than Grant's because he buys more fruit bars than Grant. So below Grant, we're going to draw Ken's bar, and his is longer because he buys more. We don't know how many yet, so that's what we're looking for. We're looking for the total of his. But we do know that he bought 230 more than Grant. So this negative space here is where we're going to label how many more he bought. He bought 230 more, so you can kind of see that, which allows them to see, so this is how many Grant had, this is the same amount as Ken, and this is the more that he had. So then we're able to see, well, if this and this are the same, this is also represented as 345. And 345 plus 230 will give us how many Ken had. So they're able to transfer the idea that this part fits there because it's the same size. So they'll have 345 plus 230, and that's going to give us our total for how many he bought. So comparison, 2 bars. The next one is a little bit different. It's when something is less. And this is the kind that I feel like trips them up the most in 2nd grade. I don't know what you guys think. I agree. Because they just think, I hear less, I probably need to subtract. Or I hear, they just hear those words and they just immediately go toward it. And they don't necessarily read through what it actually means. So this is about Alice, and she made ham sandwiches. and cheese sandwiches for a party. So again, we're gonna start out with
More food.
I told you, because every time I ask them for what we're gonna talk about, today was like the first time ever we got ducks as a request. It's always donuts, cookies, breadsticks, whatever. So I'm telling you, every time we do these problems, it's food in my room. I don't know. That might not be good. So Alice made 166 ham sandwiches. So we draw her bar first. This is for the ham sandwiches, so I'm going to label it with an H. And we know that it's 166 sandwiches. Then it says she made 77 fewer cheese sandwiches than ham for the party. So the cheese sandwich bar is going to have to be shorter than the ham sandwich bar. So when you draw that one, it's got to be shorter. We know that she made fewer. That's my cheese bar. Then we don't know how many cheese ones there were yet. That's kind of what we're looking for. So this is where we're going to get our question mark. But we do know that she made 77 fewer than this one. So we know this difference is 77. So again, we can transfer the fact that part of this is equal. So we can see that part of this bar, or this bar plus this, is going to equal the whole bar of how many ham sandwiches she made. And so again, they can solve with addition or subtraction. As we continue on, the subtraction will become easier for them and they will opt for that. At first, they will probably want to start those addition problems this way. And that's okay. So they can either do some number plus 77 equals 166, or they can do 166 minus 77 to get their answer there. And that tells us how many cheese sandwiches she made. These ones I think are by far the hardest type that we learn in second grade. The last one actually goes back to one that we just did about Grant and Ken. And this is a two-step problem. And these ones we won't hit till the end of the chapter. But the two-step ones tend to kind of trip them up. So the first part of it we've already solved, but I will redraw it for you guys. So we've got Grant, and you can redraw it if you want to. It might be helpful. We've got, Ken has to have more. Sorry. I'm thinking of cheese. Grant and Ken, and remember Grant had 345, and Ken had 230 more. That was the first part of this, and we solved for it, and we figured out that he had, 575. So the next part of this is how many fruit bars did they buy all together? So before they can even get to that part of what they're asking for, they have to figure out what Ken actually had. And so they have to go through all this work, and then they think they're done. They figure they're done. They've done a bar model, they've actually drawn two, they've compared, boom, boom, boom. But that's not actually what this question is asking. They're not asking how many Ken had, they're asking how many they had all together. So after this bar set of comparison is done, this sideways bracket over here is drawn to represent putting them together. So we know about Grant, and now we know about Ken, and now we have to put those bars together. So we can add Grant's 345 and Ken's 575, and that's going to give us how many fruit bars they sold all together. So the second part of that is the harder part, because they have to get through the first part in order for them to be able to solve the total. So those two-step ones will come after we've mastered the one-step ones. But this part will be the section over here that we go with. Do you guys have questions about any of these types of problems, or things that you want to know more about, or understand why this is the way that we're doing math right now? Does everyone feel a little bit better about bar modeling? Yeah.
Do they have to do any kind of explanation as to how they got it, or is the picture enough explanation? Is that something that comes with it?
They won't necessarily be required to write out exactly what they did,
Okay.
but we will definitely ask them to be able to talk about it. So when they're able to decipher these things, they should be able to talk about it. When we do our math journaling, they do a lot of explaining with words what they do. And so when there might be one of these that we do in a math journal, and it wouldn't be every single problem they have to write it out, but it might be something in that regard. We ask them, okay, after you do your bar model, tell me what you did and why you did it. So it's not something they would be assessed on, but it is something that we're always aiming for, because we're really trying to make them be math thinkers and not just math doers. That's what the whole point of all of this is for us to be able to understand and think about math differently, rather than just regurgitate formulas and learn algorithms and plug numbers in, because that's not really understanding what we're talking about.
I know I at the very beginning make them tell me, do we have both parts and we're looking for a whole,
Yeah.
or do we have the whole and one part and we're looking for a part?
Yeah, and a lot of mine too this year, and they're doing a really great job at this, which is a good tribute to first grade, is that they immediately drew this on their papers and on their boards, which is the number bond that they learned in first grade. And so they'd be like, oh, I know that I have the part, and I have this, or I have the whole, and I have this part, and this is the part I'm missing. So they know this part of it, so then they can translate, I've got one part, I've got the whole, I need another part, and translate it into the bar. So that is a good way for them to recognize the parts in the whole also, because that was something they really hit hard in first grade. And this is the transition from this to bar modeling. Any other questions? We're here if you do have more questions, and obviously we want to make this as easy as possible for you as well as your students. So if they come up, please feel free to email and we can help you in any way possible. Okay? Thank you guys for coming. I really appreciate it. I know it's the middle of the week and it's night and we all have things going on. So thank you.
Thank you.
Sure.